Goal here is not accuracy and efficiency. Accuracy and efficiency focuses on procedures. Improving number sense is the opposite of a focus on procedures. We need both. But today we're going to focus on the thinking, reasoning, and sense making and the gap filling methods. Hello, and welcome to Tier 1 Interventions podcast, where we talk about strengthening your core classroom, that is, and specifically your Tier 1 general core math classroom. We are support for academic and non-academic interventions here at Tier 1 Interventions for all educators, support specialists, school leaders, interventionists, and instructional coaches. Today's podcast episode is an extension of a previous podcast episode that was released on January 7th, 2025, titled Division Mastery is Easier Than You Think. We will extend on the 3 math rules that never expire, and today's episode will focus on the first extension, which is division is counting. I'm your host today, Jay-Z in the house, Jonily Zupancic, that is, and we are going to explore 2 additional cycles of division, which is a math rule that does not expire when we relate to division to counting. Here are the cycle sets that we're going to focus on today, and I'm showing you my screen at this point. If you are listening to Tier 1 Interventions podcast on your favorite podcast app or your favorite podcast network and you cannot see the visual, no worries. I'm going to explain exactly what I'm doing. However, if you re-listen to watch on YouTube at Tier 1 Interventions podcast, you will see a copy of the cycles and me acting out the notes as I'm sharing with you today. Today, we're going to look at division cycles H and L as division is counting. Rule number 1 of math rules that never expire is extended on today's podcast. Cycle H looks like this. Here are the 4 problems that I will read to you. Cycle H is 8 divided by 4, 8 divided by 1/4, 96 divided by 4, and 4.5 divided by 0.25. Those are the problems in cycle H. We're going to walk through each of these problems with the philosophy of using division as counting for the purpose of improving number sense, thinking, reasoning, and sense making, also improving contextual, conceptual, sensory, minds on approaches to math achievement. The goal here is not accuracy and efficiency. Accuracy and efficiency focuses on procedures. Improving number sense is the opposite of a focus on procedures. We need both. But today we're going to focus on the thinking, reasoning, and sense making and the gap filling methods, thought processes, and mindset that we need students to have to improve their number sense and fill those gaps of their lack of understanding of number. So the first problem, 8 divided by 4. Typically, I like to use paper strips. You can use any objects. 8 divided by 4, I could show this visually with paper strips, but we need to define, remember, that the second number in division is my counting number. It's my skip counting number. And my land on number is the first number, which is 8. So I'm going to skip count by 4s. So I'm going to write a bunch of 4s here. 4, 8, 12, 16, 20, skip counting by 4s. However, if students have a deep understanding of division and skip counting in general, and as we're improving their number sense, the question becomes, when do we stop? We stop when we get to this land on number. So the question is, how many skip counts does it take to land on 8 if we're skip counting by 4? 4, 8. Didn't need these skip counts. But again, this is not about efficiency and accuracy. It's about experimenting and experiencing mathematics to improve our number sense, which is a conceptual, contextual, sensory, emotionally based skill that students need to have to improve overall math achievement. If we're using our paper strips, we can actually have 8 paper strips, skip count by chunks of 4. So there are ways that we can use tools to be able to do that. Let's look at our second example. Same method. Our skip counting number is 1/4. Our land on number is 8. I'm going to treat this just like I treated the previous one. Here is the power and impact of these division cycles and treating division as counting. Again, the impact is not efficiency and accuracy, which ultimately we're going to get there. But without focusing on that first, we can focus on generating good number sense and estimation skills with students. We're also going to focus on the same strategy, and I can, with my second and third graders, my 8, 9-year-olds, I can introduce them to division problems with fractions before the standards say that we're going to expose to them division problem with fractions. The reason I can do this is division is just counting. So my counting number is 1/4. So again, I'm going to write down a bunch of 1/4, 1/4, 1/4, 1/4. So it is really a great exercise in improving number sense to skip count, but oftentimes we do not extend that to skip counting by fraction. So 1/4 and 1/4. So kids are going to want to say 2/8. However, we go to this paper strip and we fold in half twice to make 4 equal parts. Each part has a value of 1/4. So by using this manipulative, by using this math tool, by using this sensory, concrete, hands-on experience, students can see that this is a value of 1/4. And so if I have a 1/4 and another 1/4, I just have 2 of those fourths, 3/4, 4/4. So we have to teach kids how to skip count by fraction. And one way that I do this, especially for my younger students and my struggling students, is instead of writing the symbol 1/4, I write the number 1 and the word fourth. So this is what I do with my 5, 6, 7-year-olds when we're skip counting. We're just skip counting by whole numbers with a word that describes the size of what we're skip counting. So we can eliminate the notation and still give younger students or struggling students access to division by fraction. So I'm going to count 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, etc., etc. Now, how do I know when to stop? When I have a paper strip, 4/4, that equals 1 whole paper strip. So once I get to 4/4, I have 1 whole paper strip. Now, if 1/4 is my skip counting number, my first number in the division problem is my land on number. I want to land on 8 or 8 wholes or 8 full paper strips. So I have to lay out 8 full paper strips just like this and count how many of these pieces I have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I count all of these. Once I figure out how many pieces I have, I will see that I have 32 pieces. 32 of what? I write the word FOURTHS. I have 32 counts, basically, 32 fourths is what I was counting. So the question is, if I skip count by 1/4 to land on 8, how many counts will that take by fourths? It will take 32. So the answer to 8 divided by 1/4 is 32. Now let's use the same strategy, but now we're going to have a little different feeling about this when we see the third example, 96 divided by 4. Again, the second number is 4. That is our skip counting number. 4, 8, 12, 16, 20, 24. Now I know what you're thinking, dot, dot, dot. My land on number is the first number, which is 96. I know what you're thinking. Why in the world would we ever use this method of skip counting for division? Because this is not efficient and there's a lot of room for error by skip counting so many counts. But remember, this is to improve number sense. Improving number sense is often negated by using procedures that focus on accuracy and efficiency. Accuracy and efficiency are of the utmost importance. That is our ultimate goal. However, along the way, if we continue to negate number sense, our kids look at a problem like this, 96 divided by 4, and have no sense of estimation of whether that's going to be a large or a small number. Let's go back to our previous examples. 8 divided by 4. Because I know this skip counting method, I can look at those numbers and say to myself, oh, that's not going to take a lot of counts. If I look at 8 divided by 1/4, I might initially look at that and say, oh, that's not going to take a lot of counts. Maybe it's going to take 2 counts. But as I start to skip count by 1/4, that's where the gap filling happens. So students are going to look at this and they're going to say 8 divided by 1/4. The answer is 2. It's going to take 2 counts to land on 8. Perfect. Let's go through the non-efficient, non-procedural process. It's only then when kids are forced to go through the non-efficient, non-procedural process that they discover themselves the error in their thinking and they start to fill in those gaps with solid ground, improving their number sense. 1/4, 2/4, 3/4, 4/4. Oh, I only landed on 1. 5/4, 6/4, 7/4, 8/4. Okay, it took 8 counts to land on 2. Gosh, I got to get to 8. Now I can look at division problems and have a concept for estimation. Students that have dyscalculia or struggles with mathematics or the identified math learning disability cannot effectively estimate. Without those estimation skills, I can never achieve accuracy and efficiency. So we must fill in the gap with conceptual skills to achieve maximum efficiency and accuracy through procedures. Estimation skills are the first skills we want to build with students that have struggles in mathematics or an identified learning disability such as dyscalculia. So you can see the progression of this process. Again, it's not about procedure, it's not about efficiency. But what I want is I want kids to look at this and say, okay, my second number is 4. That's my skip counting number. My land on number is 96. Oh my gosh, that's going to be so many counts. I need a different way to do this quicker. That's what we want students to be begging for. If we want students hungry and thirsty for mathematics, we need to put them through experiences just like this, wrapping their mind around division being skip counting, that's accessible for everyone, to then improve their estimation of a computation problem and ultimately be begging for efficiency and accuracy.
Hey everybody, Cheri here. I'm just interrupting Jonily for a moment because I just wanted to share something that we have coming up on August 13th. We have a masterclass that we are going to be doing for you. So here's what is included in that masterclass. We're going to show you how we pre-plan, we plan, and we present lesson plans. They aren't the same as what you might think when you're thinking of a traditional lesson plan. So I just want you to hear me. When Jonily is preparing a lesson plan, she uses an indirect model rather than a direct instruction model to set up her instruction. So tune in on August 13th so that you can hear what she has to say. We're also going to give you the slides and some printable downloads that you can use right away. And I know OTs are thinking, how do I get involved? It's not just OTs that can benefit from, our math teachers that can benefit from this program. See, OTs listening to this, we can share the message on how crucial intentional body movements, hear what I say, crucial intentional body movements are during instruction. So if you tune in, we can share a little bit about how the OT can interact with the math teacher. But these aren't just for math lessons. These are also for social studies and science and music and art and reading as well. So it's the style of this curriculum. Okay, so I say curriculum, but it's not really a curriculum. It's a program that helps learning match the way the brain learns. So in the show notes, you're going to find the registration link. So stop the recording right now, go into the show notes, click on that link, get registered, and we will see you on August 13th. Now let's see how Jonily pulls all these pieces back together to finish the division cycle.
Now, I'm not going to go into the instruction that we do here on how to build efficiency and accuracy, but I do want to point out here that the number selection is important, and that is why our division cycles, subtraction cycles, any of our cycles that we create, we've deliberately and intentionally chosen specialty numbers. 96 has been chosen because there's not going to be a remainder. But 96 has also been chosen because it's not a number like 40 or 80 that many kids can see what that answer is going to be. The reason it's 96 is it builds on this understanding of 40 and 80. It doesn't get to the next 40, 120. But from 80, I've added on a multiple of 4, 16 more than 80, so that there's no remainder. But by looking at this number 96, you don't automatically know the answer. So when we're talking about efficiency and procedurally, just know that the number selection here is going to support that instruction, but that is not what we're going to focus on today. Our final example here in cycle H is 4.5 divided by 0.25. When we see decimal numbers, I have trained students to think of money. So same process though. Our second number, 0.25, 25 cents, that's a quarter if we're thinking of coins. That's our skip counting number. So we're skip counting by quarters. We're skip counting by 25-cent pieces. We're skip counting by decimal 25. So I could actually draw quarters or have play money. So look at this, like in earlier grades, when we're talking about money, it's important to skip count by certain coins, because then this division problem is accessible for kids that are starting to master this idea of money. So if I'm skip counting by quarters or decimal 25s, I know that for every 4 counts, I end up with $1. My skip counting number is 0.25. My land on number is 4.5, which $4.50. Sometimes kids think that's $4.05. There's another instructional method to negate that misconception, not focused on today. But if I do 4 skip counts, I land on one. 8 skip counts, I'm going to land on $2. 12 skip counts, I'm going to land on $3. So my goal is to land on $4.50. So you can see how accessible this division problem is, even for 5, 6, 7 year olds, as I'm just counting by quarters, counting by 25-cent pieces. I may not show this problem or the notation to those kiddos, but I'm going to do this exercise in my classroom so that they understand that when I'm skip counting, I'm formulating these division problems. If students are struggling to skip count, as I look at cycle L here, we're going to look at one more cycle, but we're not going to do every problem. The second whole number, which is our skip counting number, here it's 8. And if I go back to the previous problem, it was 4. As students are maybe struggling with those skip counting numbers, on the third page of our notes, we have a 120 chart where we can help students identify those numbers by using this visual component also, in addition to the paper strip. Now, notice what I'm doing. And if you can't see this and you're just listening to audio, I'm going to tell you what I did. I circled 4, 8, 14, 18, 24, 28. Kids will think that that is a combination of skip counting by 4s and 8s. However, we use another method, which is creating a dot pattern. If we're going to skip count by 8s, a dot pattern of 8 and whisper count to the next number. So if I create my dots, I have 8 dots. I circle the number 8 because 8 is 1 8. How much are 2 8s? I can whisper count touching my dots. The next number after 8, 9, 10, 11, 12, 13, 14, 15, 16. So the loud number is 16, and I can utilize whisper counting to give access to 120 chart. I can utilize 120 chart to give access to skip counting by whole numbers. I can also use the paper strip, so I'm going to relate the 120 chart skip counting to the paper strip skip counting once I get to those fraction numbers. So there's all of these layers of scaffolding that's going to be improving number sense in every iteration of these cycles that we use. Division is skip counting is the number one rule that never expires in mathematics. Division is lots of other things, and there are many other perspectives of division. But if our goal is to create a core tier 1 math classroom and strengthen the regular classroom that every student can have access to complex material, we want to focus on these 3 math rules that never expire. Number 1, division is skip counting. Number 2, subtraction is distance. And number 3, multiplication is rectangle. Again, this podcast is an extension of a previous podcast called Division Mastery is Easier Than You Think. Today's podcast is Division A to Z. We're leveling it up. It's the extended version. Get your notes that you watched me create in the show notes by linking below and comment what thoughts and ahas you've had with this episode. Also, you can subscribe so that you get access to more content just like this. I was your today's host, Jonily Zupancic, with an extension of Division is Counting with Tier 1 Interventions podcast.